You ever really think about that? How in the world can a person with just 1 foot lift something that weighs thousands of pounds? I mean, it seems like it should be totally impossible, right? Well, it's not magic, it's physics. And the idea behind it is just so simple and so powerful. The secret to this super strength? It's all thanks to one of the most incredible principles in all of engineering, hydraulics. And today, we're going to break down exactly how this system works and how it gives us, almost superhuman abilities using nothing more than a little bit of fluid.
Okay, so let's start with the absolute basics. What is a hydraulic system? Well, at its core, it's a force multiplier. It's a technology specifically designed to take a small, easy bit of effort and just blow it up into this immense, world-moving power.
Now, you might be thinking, what's the catch? And you're right, there is a trade-off. It's a fundamental rule of physics, actually. You apply a small force over a longer distance on one end, and what you get out is a massive force over a shorter distance on the other. You're basically trading movement for power. And let me tell you, it is an incredible return on your investment of effort. So how is any of this even possible? Well, the entire world of hydraulics is built on one simple law figured out way back in the 17th century by the brilliant Blaise Pascal. And it is so simple, but its implications, they are absolutely massive. This right here, this is the whole secret sauce. Pascal's law. Now, the two key words you really got to focus on are confined and incompressible. Because the liquid is trapped in a closed system, and because you can't really squeeze it, any pressure you put on it at one point gets transmitted perfectly and equally through the entire fluid in every single direction. It doesn't lose any strength along the way. And this is the really crucial part. That fluid, which is usually some kind of oil, just cannot be compressed. It's not like a sponge or a spring. When you push on it, it doesn't shrink down. It has literally no choice but to push back and transfer that exact same force somewhere else. That is the secret ingredient. Think of it like this. Picture two syringes, one small and one big, connected by a tube. When you push down on that small piston, you create pressure in the fluid inside. Instantly, that pressure travels everywhere. But here's the magic. When that same pressure pushes up on the much larger piston on the other side, bam, the output force is massively magnified. That's Pascal's law in action, right there.
All right, so we've got the principle down. Now let's look at how it all comes to life inside a real system. Every single hydraulic machine has a core cast of characters, and each one plays a super important role.
So first up, you've got the reservoir. This is pretty straightforward. It's just the tank that holds the system's lifeblood, that hydraulic fluid. It keeps it safe, clean, and helps keep everything cool. Next, we have the heart of the entire system, the pump. The pump's job is to pull that fluid out of the reservoir and start forcing it through all the lines. This is what creates the flow and the pressure that's going to do all the heavy lifting. Now, if the pump is the heart, then the valves, well, they're the brains of the operation. You can think of them as a series of gates and switches, kind of like traffic cops. They tell all that high-pressure fluid exactly where to go, when to go there, and when to stop. This is what gives you such precise control.
And finally, we get to the muscle, the actuator. This is usually a cylinder with a piston inside. When that high-pressure fluid gets sent here, it rushes in, shoves that piston, and converts all that fluid pressure back into powerful, real-world mechanical force. This is where the work gets done.
So we've met our cast: the reservoir, the pump, the valves, and the actuator. Now let's put it all together and see how they all work together in one seamless, powerful cycle. The whole thing is just a beautiful sequence of power transfer. Okay, so the pump grabs fluid from the reservoir and pressurizes it. Then the valves, our little traffic cops, open up and direct that high-pressure flow right to the actuator. The fluid floods the cylinder, shoves the piston, and just like that, you have movement. A car gets lifted, a bulldozer's arm swings, a giant press stamps out a piece of steel. It's that simple. Now, this technology might sound like it's for heavy industry, but the truth is, it is absolutely everywhere. Once you know what you're looking for, I promise you're going to start seeing the hidden power of hydraulics all around you. I mean, this technology is so fundamental, we just take it for granted. You see an excavator digging at a construction site? That's pure hydraulics. The brakes that stop your car? Yep, that's hydraulics. The landing gear on a massive airplane? You guessed it, moved by hydraulics. It's truly one of the foundational technologies of our modern world. It's not magic, it's physics. and it's the physics that moves our world. That just sums it up perfectly, doesn't it? What seems like an impossible task, lifting a 2-ton car with 1 foot, is really just a clever application of a basic law of nature. It's the science that lets us build our cities, fly through the air, and shape the very world we live in. So now you're in on the secret. The next time you see some massive machine doing its thing, you'll understand that quiet, immense power that's driving it from the inside. You'll know it all comes down to a trapped liquid and a brilliant principle that lets us achieve things that feel superhuman.
This incredible principle allows us to magnify our own strength to an almost limitless degree. We see it in everything from the delicate touch of robotics to the awesome power of industrial machines. It really makes you wonder, doesn't it? Now that we've mastered how to multiply our force, what other impossible problems will we solve next?